Okay, chapter 6 is on exponential and logarithmic functions. So let's start with an exponential function. So we're going to graph, actually let me tell you, an exponential function is when the variable is in the exponent place, and that's why we call it exponential. We're going to graph f of x equals 2 to the x using a table so we can kind of get the shape of the graph. And then we'll make some generalizations. Okay, so if I plug in x is 2 up here, what is that? That's 2 to the second power, 4. 2, 4 is up here. Okay, I'm going to plug in x is 1. So 2 to the 1 is 2. 1, 2. Okay, if I plug in 0, 2 to the 0 is 1. Okay, now when I plug in negative 1, I have 2 to the negative 1. The negative flips it to a fraction. So at negative 1, it's about 1/2, so I'm going to estimate about there. One more. Okay, what about if I plug in negative 2? I get 2 to the negative 2. So 2 to the second is 4. 2 to the negative 2 is 1/4. So at negative 2, I'm going to go to 1/4, which is really low, but it's still positive. Okay, this is the shape of the graph. It starts low, and then it goes up. It never goes to the negatives because no matter what exponent I give it, it just makes it positive. So this is an asymptote. Okay, let's try 1/2 to the x, and then we'll look at the generalizations of it. Okay, so if I plug in 2 for the x, I get 1/2 to the second. So 1 squared is 1, 2 squared is 4. So at 2, I'm just going to estimate around there. Okay, 1/2 to the 1. Well, that's just 1/2. So at 1, 1/2, I'm going to estimate. Okay, 1/2 to the 0 is 1, because anything to the 0 is 1 except 0. Okay, now if I do 1/2 to the negative 1. The 1 doesn't do anything, but the negative is going to flip it. So instead of 1/2, it's 2/1, which is 2. So negative 1 is going to be 2. Okay, now if I do 1/2 to the negative 2. So if I do the 2, I get 1/4. The negative is going to flip it. So instead of 1/4, I get 4/1. So at negative 2, I'm going to go up to 4. Okay, I'm going to sketch the curve in. This time it starts high and it kind of goes down. It will not cross the x-axis, so I'm going to keep it above the x-axis. Okay, this is what an exponential graph generally looks like. The one on the left over here, it starts low and it goes high, so it's growing or it's getting higher. So this is a model of exponential growth because it's getting higher. Okay, if I start on the left side, this one starts high and it goes down. This is called decay because it's shrinking. It never goes away, but it keeps shrinking and shrinking and shrinking. Okay, let's consider a graph of y equals b to the x so we can graph these without having to make a table every time. Okay, the first thing, if I looked at this, it never crossed the x-axis. It always stayed above the x-axis, which means the asymptote is a horizontal line and it's at 0. So there's an asymptote at y equals 0. Okay, on our graph, y equals 0 would be the x-axis, which is hard to draw because it's right on top of the axis, but just know it's never going to cross that line. Okay, the y-intercept is when x is 0. Okay, if I plug in x is 0, I get b to the 0. Anything to the 0 power is 1, except 0 to the 0, and we're not going to do 0 to the 0 because it doesn't make sense. So once I get the y-intercept, I have a next point. Okay, now the next point depends on what my base is, and it can change depending on the base. Okay. I'm going to plug in 1. If I plug in 1, b to the 1 is b. I don't know what b is. So whatever it is, I'm going to go to 1, and that's going to give me my b value. Okay, now if I do b to the negative 1, I get 1/b. I don't know what b is. So I'm just going to guess. It's going to be somewhere over here. If I plug in negative 1, I get 1/b. Okay, since I know what the graph looks like, my goal is just to make it look like it's an exponential graph. So this one starts flat and goes up. I don't know if that's really true, but it might be true. Okay, this is saying the base is greater than 0, 0 is less than or equal to b. Ugh. Okay, this is growth or decay. So for this graph here, it was an example of growth. The reason it was growth is because I was timesing by 2 every time. Since 2 is higher than 1, every time I multiply by 2, it ends up growing. So if b is greater than 1, this is a model of exponential growth when the base is greater than 1. Okay, if the base is between 0 and 1, like this one was 1/2, it's getting smaller every time. So it's going to be a model of exponential decay. Okay, let's try to graph some exponential functions where the base is changing, and then we're going to indicate whether they're growth or decay. Okay, I'm going to include at least 3 points. Okay, now if I look at this f of x equals 3 to the x, the base is 3, so this should be a model of exponential growth because the 3 is bigger than 1. I'm going to graph it and make sure my graph looks like it's exponential growth. Okay, the first thing I know is that there's an asymptote at y equals 0. Y equals 0 is right on the x-axis, so graphing it's not, you can't really see it, but I have to know that I'm never going to cross that line. Okay, the next thing I'm going to graph is that the y-intercept is going to be 0, 1, because if I plug in 0 here, 3 to the 0 is 1. So 0, 1 is my give me point. I'm going to get that right away. Okay, the next point I'm going to do is when I plug in 1. If I do 3 to the 1, I get 3. So at 1, I go to 3. Okay, now I need a second point. I could do 3 to the second and all that, but normally it's safe if I do 3 to the negative 1. If I do 3 to the negative 1, I get 1/3. So on the negative side, I'm going to guess it's about right here. Because I know the shape of an exponential function, I know that this must be the low side and this must be the side that's going up. So it started low, it went up, which means it's a model of exponential growth, which is what I thought it was going to be. So my graph matches my expectation. Okay, let's try the next one. This is g of x equals 5 to the x. Okay, the base is 5. 5 is greater than 1. So this should be exponential growth. I'm answering the question now, but then I'm going to look at my graph at the end to make sure that's actually accurate. Okay, my asymptote should be at y is 0, which it's right on the x-axis, so you don't have to draw it, but you have to know that it's going to stay on one side of that asymptote. Okay, what am I going to do? I'm going to do the y-intercept. 5 to the 0 is 1, so 0, 1 is my y-intercept. Okay, now if I plug in 1, 5 to the 1 is 5. So at 1, I'm going to go up to 5. 1, 2, 3, 4, 5. That's my first point. Okay, I'm going to do a second point because it asks for 3 points. 5 to the negative 1 is 1/5. So on negative 1, I know it's going to be really, really low because 1/5 is really, really low. I don't have to label it. I'm labeling it because your notes. Okay, so based on this is a clear point. This is a clear point. This is my estimate, but that's enough information for me to know that this is starting low and it's increasing on the right. So this is a model of exponential growth, which is what I thought, and now my graph has 3 good points. Okay, let's try a couple more. Okay, in this case, my base is 1/4. 1/4 is not higher than 1. So I'm expecting this to be exponential decay. And I could graph it first and figure that out. Okay, my asymptote is at y equals 0 because it's not moving, not today. My y-intercept is still 0, 1. So let me graph that point because that's my gimme point. Okay, now let me get a couple points. If I do 1/4 to the 1, I get 1/4. So 1, 1/4, which is good because it tells me it's going to be down on the right. Now I'm going to do one more clear point. Let me do 1/4 to the negative 1. What does the negative do? Exponent, it flips it. This is 4 over 1, which is 4. So at negative 1, I'm going to go up to 4. 1, 2, 3, 4. So my next point is negative 1, 4. This was 1, 1/4. I don't need to label them. It didn't tell me to, but I need to see those points. Okay, so I know that it's going to go this way. And it should not cross the asymptote, so keep it above the x-axis. Okay, when I look at this from left to right, it does look like it's decaying because it's getting smaller. Okay, and I have my 3 points. Okay, D, let's try a trickier one. Okay, let's see, what's my base? My base is 3/10. 3/10, that's lower than 1. So this should be exponential decay again. Okay, my asymptote is still y is 0, which is right on the x-axis, which means drawing it is kind of not that useful. Okay, the y-intercept is 0, 1, because anything to the 0 is 1 except 0. Okay, now I'm going to do 2 points. If I do 3/10 to the first power, I get 3/10. 3/10 is low, so maybe like right here. 1, 3/10. Okay, now let's do negative 1. So if I do 3/10 to the negative 1, the 1 doesn't do anything, but the negative flips it, so I'm at 10 over 3. Okay, 10 divided by 3, what is 10 divided by 3? Well, 3 goes into 10 3 times with the remainder. So it's 3 point something. So at -1, I'm going to go to 3 point something. So -1, 1, 2, 3 point something. I'm guessing it's about here. If you want to put it in your calculator, you can put it in the calculator. You get 3.3333. Okay, so at -1, this is 10/3, which I estimated is 3 point something. Okay, so this is the graph this is the side that goes high. This is the side that goes down. And I do have 3 points on there, which I know they're exact values, even though I guessed when I graphed. Okay, and it does look like a decay function, which is what I was expecting. Okay, now exponential models are often used in finance, in science, so you see them a lot. Okay, they're calling this the exponential growth model, and this is the exponential decay model. No, it's not. That should be a minus sign. One moment. This should be a minus. Okay, y is the amount after time t. So if it's 3 months, I plug in 3. If it's 5 hours, I plug in 5. A is the initial amount. It's what I started with is the A. R is the percent of increase or decrease. Okay, so let's see when this might come up. Okay, it says the value of a car Y in thousands of dollars can be approximated by the model Y equals 25 times 0.85 to the T. This is an exponential model because the variable is in the exponent spot. Okay, T is the number of years since the car was new. Okay, the first question asks, tell whether this model represents exponential growth or exponential decay. Okay, to figure that out, I just have to look at the base. I don't have to graph it. The base is whatever the exponent's on. So the base is 0.85. 0.85 is lower than 1. So this is going to be exponential decay. And why? Because 0.85 is lower than 1. Okay, it says identify the annual percent increase or decrease in the value of the car. Okay, where do we talk about the percent increase? The percent increase is R. Since I'm doing decay, it's the amount that was subtracted from 1. Okay, so I have 0.85 here. And it's decaying. If there were a 1 here, I want to see how much lower than 1 it went. So I'm going to do 1 minus 0.85. Now I'm going to use my calculator. I got 0.15. So the annual, well, it says percent. The decimal increase is 0.15. To make this a percent, I multiply by 100. So this is going to be a 15% decrease. It's a decrease because it's lower than 1. Okay, the last question asks, what is the value of the car after 7 years? 7 years. Okay, let me go back to the problem. Where does it talk about years? Blah, blah, blah. T is the number of years. So I'm going to plug 7 years right here. Okay, so y equals 25 times 0.85 to the 7 years. Okay, now I'm going to put this whole thing in my calculator at the same time, and I'm going to get the answer because it's going to be a decimal anyway, so let's just accept our calculator as part of our lives. Okay, now you can put this whole thing in your calculator at the same time. Try to type it exactly as it looks. Okay, I did it and I got 8.014. Let me keep like 3 decimals. Okay, now I'm going to go back and read the question because the value of the car is not 8.014. I'm very sure of that. Okay, why? The value of the car Y in thousands of dollars. So this is thousands of dollars. So the car is about $8,000. Okay, so the car's after 7 years, the car is now worth about $8,000. Initially, what was it worth? Initially, it was worth 25. Now it's worth 8. Okay, let's try one more that's like that. And these look crazy, but we're going to read them, and they're not that bad. Okay, so this is the population of Arendelle in 2000. Y and hundreds of people can be approximated by the model y equals 5 times 1.08 to the t. Since the exponent is a variable, this is an exponential model. T is the number of years since 2000. Okay, first tell whether the model represents exponential growth or decay. So I'm going to look at the base. The base is whatever the exponent is being applied to. The base is 1.08. Is that higher or lower than 1? It's higher than 1. So this is going to be exponential growth because the base is bigger than 1. Okay, identify the annual percent increase or decrease in the population. Since this is growth, this should be increasing. Okay, let me look at the equation for increasing. Okay, if this is growth, my rate is going to be 1 plus something. So what is my base? It's 1.08. So I'm going to do 1.08. I'm going to minus 1 to see what my rate was. What is that, 0.08? Okay, that's my rate as a decimal. To get it as a percent, I need to times by 100. If I times by 100, I get 8%. Since this is a growth model, that's an increase. The population is increasing by 8%. Okay, the last question asks, what is the population of Arendelle in 2023? Okay, let's go back and see what we need to plug into the equation. Something about the years. Is it the end? Yeah. T is the number of years since 2000. So if I'm in 2023, then T is going to be 23. So let me plug that into my equation. Y equals 1.08 raised to 23. And I'm just going to put the whole thing in my calculator. I'm going to get a decimal because exponential models often do this to us. Okay, let me write my answer, and then I'm going to go back and read the question so I can write the answer properly. So I got Y equals 29.357. Okay, let me see what Y is. The population of Arendelle in 2000, Y in hundreds of people. Okay, Y is hundreds of people. So we're going to approximate this. So this is about, I got Y is about 29. So this is about 2,900 people in Arendelle in 2023. Let's see, how many did it start with? Okay, it started with only 500 people, apparently.